Okay, in this tutorial we're going to create a lift-off plume as this rocket takes off, which is basically going to be coming out through these channels in the base launchpad geometry that we've got in here. So if we just quickly scrub through the sequence, I'm just going to turn off wireframe here, just scrub through, we'll see this animated camera swing around and the arms retract and camera zooms out and we follow the rocket taking off. So we've got kind of a little bit of a handheld camera motion going on there. If I just switch to wireframe, we should be able to scrub through this a bit quicker. There we go. Okay, so what we have in this scene is obviously the animated rocket, which is animated simply by animating this dummy Sat5 object in the scene. A load of other things obviously linked to it, like for example these lights, and if we look very carefully we have 5 particle flow source icons within the viewport already set up for us. So they are set up within particle view, ready for us to start working with. Now these have the initial parameters already set up, like for example the viewport quantity multiplier is already set to 100%, so it matches out at render time. The particle amount upper limit is clamped off at this high value here. If you're loading this in a 64-bit version of 3ds Max, this is actually a 32-bit version. I actually designed it in the 64-bit version, but it's been optimized down so it's compatible with 32-bit versions because of obviously memory overhead. You'll notice that this value is actually higher. Next thing is the integration step. Within the viewport we've viewed it at half frame just so we can see no particle leaking through the base geometry down here and any deflectors that we set up. And also at render time it's set to 1/8 of a frame, which is quite a low integration step, quite simply because we want to be able to see changes in displacement and scaling, etc. At a subframe level. So if a particle goes from here to here over the space of a single frame, we want to be able to make sure that it breaks up, or sorry, it expands outwards or displaces outwards accordingly during that, and not just pops into its large state. Okay, we also need to make sure that particles do not leak through the geometry, which is obviously going to be this guy here. This sorts out the direction of the animated particles to fling them out, so they emit from here and then go out like this. Okay, so we have this animated scene to start with, which is obviously already set up for you. So the thing to note is exactly when this thing decides to take off. That's going to be around about frame 200. However, we obviously need to get the plume in to start with. So anyway, we'll start at the beginning and we'll start adding in some space warps. Actually, before we do that, what I want to do is just quickly go through some of the render parameters that we've already got set up in here for you. Okay, so we've got a active time segment which is 0 to 500. Now what we might do when it comes to rendering this out at the end of this tutorial is just render from frame 160 onwards, which is going to be when the plume is actually added to the actual scene. So just for example purposes, I mean the final sequence is going to be on the DVD, which is the full 500 frame duration. However, just to show you that this thing is actually working at the end, we'll render it from frame 160, otherwise we're going to be sitting here waiting for quite a while. Okay, so we've got the frame active time segment, which is 0 to 500 already set up. The output size is set to quite a low resolution just for preview purposes. If you want to render this out larger afterwards, then feel free. However, obviously the render times are going to go up quite substantially. The renderer for production is set to mental ray, and the material editor is set to scanline, just quite simply because of material update speeds. In the renderer tab we have pretty much the basic standard default setup. However, I've taken the bucket width down to about 24 as opposed to the default of 48, just so that more buckets are available within the scene, just so that we are using the maximum amount of CPU time available. if a bucket was like, for example, this big and the plume is this big, there's only going to be one CPU going to be working on it. So I've decided to halve it so we get at least a couple working on the plume as it's out here and obviously out here as well. So we're maximising the amount of CPU time available to us. No motion blur within the shot at the present time. Anyway, we're actually going to be adding some in later on through a different shader, which is the HDR image motion blur shader, which is going to be added into this output rollout down here. The displacement has also been tweaked slightly as well, basically to optimize the geometry, so it's not going to be as too refined. I mean, if you want to amend this later on to get a more defined smoke pattern, or if you start seeing edges in the smoke once you actually come to rendering it, then you can obviously tweak this value down if you've got enough memory in your system, obviously. Also, the maximum displace has been increased, so we don't get any capping off of the displace. Okay. One or two other things to note. Indirect illumination is set to default, which is final gathering setting here. It's set to the default custom value for 3ds Max 2009. Again, if you're using the 3ds Max 2010, it might be displayed as something slightly different. However, in 2009, this is the default value that you get. Nothing else within here. We're not using any GI or any caustics. However, feel free to add those on afterwards. I'm just trying to pull that down there. And one other thing to add is that I have actually increased the memory limit available to Mental Ray. That is normally defaulted at 640. However, I increased it to 1024 just so there's more memory that's being piped into the system. Now, if we didn't do that, then there would more than likely be a crash, because it would run out of memory, quite simply because the amount of geometry that's being generated within the particle system, well, with the particle system being displaced, the actual material displacement that's going to be introduced later on to create these nice kind of plumes that we're going to adding in a second. If you're running 3ds Max 2010, this value is not present. Okay, the system calculates it all internally. So if you're running a 32-bit system and you're seeing crashes, then I apologize. However, I cannot change the way Autodesk design these things, unfortunately. Actually, one last thing that I forgot to mention, and it's actually quite important, is that within the renderer tab, what I've actually done is I've actually increased this max trace depth here and increase this max refractions value here. I've actually taken this reflections down as well, because we don't really need that many high reflections within this thing, but this maximum refractions is quite important. Now, the reason behind that is because the amount of times the system will actually look through the resulting plume material that we are going to be creating. Now, there's going to be a considerable amount of intersecting geometry and intersecting particles. So the problem is with regards to the mist shader that we're going to be using to derive the opacity. Now, once it actually gets past this particular well, the default value of around, which I believe is around about 6, the resulting color that it derives is it simply displays black. So therefore you will have quite a substantial amount of black patches within the actual plume itself. So to get around that, we need to trace further back. You need to do a lot more kind of traces within the actual plume itself. So therefore by simply increasing this value up to 50 and this one and so on as well, we get around that issue. Now, if there were any refractive objects in the scene, then we'd obviously have a little bit of a problem. So hence being able to composite this effect into a comp shot later on would obviously be the solution. Obviously, wouldn't render this out flat in a production render, obviously. However, for this particular instance, we don't actually have any refractive objects. We've only got a few reflective objects within the scene, which is mainly to do with the actual rocket itself. So we don't need to worry necessarily with high reflections or high reflection tracing, or don't need to be concerned themselves with the maximum refractions that we've actually got present in here, quite simply because, like I say, we don't have any other refractive objects. We don't have anything that's see-through or transparent, etc. So with that all noted down, I think we'll start creating some of the aspects of this particular sequence. Okay, so the first thing we'll do is start creating some of these space warps. So I'm going to switch to the top viewport and create a U deflector space warp. I'm just going to turn the grid off there. So let's go to the deflectors tab here and create a U deflector and just add that in the scene. And I'm going to label that as U deflector launch pad. There we go. This is so that any particles which interact with these channels that have been modeled into this launchpad base can be funneled down the relevant areas. Okay, so we've got this. I'll just switch to default lighting. Just to make sure that they don't spread out of this area here and out here, for example. They need to go along these channels down here and across here, obviously, as well. So what I'm going to do is switch back to that, go back to the top viewport. There we go. So we need to add in this launchpad geometry here. Now we don't need the particles to literally bounce off surfaces with exactly the same amount of energy, so therefore we need to amend these values. So therefore I'm going to set the bounce down to about 0.3, increase the variation to 25%, and set the chaos, which is obviously the random variation of bounce angles, to about 15%, and we'll add a little bit of friction in there as well, about 5%. Okay, so that's that one sorted out. Now the next thing we need to do is sort out the directional deflector. Now that is the piece of geometry in the scene that I mentioned earlier on, which is this guy here. So when the particles travel down, they sculpt around, or they follow the path, or bounce off the geometry. So they travel down here, boink, and go in that direction over there. So what I'm going to do is I'm going to copy this U deflector, because a lot of the parameters have already been set up. I'm going to copy that and rename it. Let's call it U deflector box direction. There we go. And then we'll choose this box direction geometry in the scene. Now this isn't actually renderable. If I go to this object properties, you can see that it's not actually renderable. It's just designed to get the particles to bounce off and follow and channel them down these channels at the end of the day. We're not actually going to be seeing this area within the render. Now if you were, then obviously we need to have this slightly smaller and get the plume to billow out and have some more particle interaction in there. Because we don't actually have this by default, it's slightly difficult to simulate, so therefore we're just having to massage the particles direction by adding in this deflector. Okay, so the next thing I need to do is to set up the base properties within particle flow. So by hitting the 6 key, let's just bring up particle view here, and then what I'm going to do is I'm going to set up a base event here, and then we'll duplicate it across so we get some different variations between each particle that's emitted from this from these 5 particle flow icons which are at the base of these engines down here. So we don't want them all to be pulsing exactly the same, because if we have the same rate or same speed that's all piped into one event, then we'll get a lot of repetition throughout the actual effect. So therefore we need to break that up. So we need to set all the individual parameters for each engine first, and then pipe the entire thing into additional events afterwards, which can then control particle interaction and deflection and so on. Okay, so the first thing I'm going to do is to let's drop in a birth operator in here. Okay, and then I'm gonna wire the output of this engine 01 to the input of this event 01. I'm going to rename this guy. Let's call it Plume birth 01. However, we need to animate the amount of particles being emitted from this guy here, quite simply because we need an initial plume coming out and then a nice constant trail afterwards. So we get a nice bulbous plume coming out to create the nice displacement over here, the nice kind of mass of particles here, and then the constant trail of particles going into it. So therefore what we'll do is set this particle system, so this birth operator here, to rate, and then what we'll do is we'll set the emit start actually to a value of 160, and then set the emit stop to 500, because that's the actual duration that we actually want this to occur. So therefore the particles start at frame 160, which is obviously here, and then carry on to the end of the sequence. I know the rocket actually only takes off at around about frame 200, but we need this kind of initial build up to start with. Okay, so 60 is a little bit too low, so I think what we're going to do is we will animate the rate to start with, so we have a larger amount to start with, and then it trails off to this constant stream. Now again, I've actually optimized the amount of particles within this shot. Now because of the motion blur that we're going to be using, they kind of blend together quite nicely as it is. However, if you start to notice gaps between the particles, then you will need to increase the rate, or an easier way, instead of reanimating this value here, is simply just go back to these PF source icons here and simply amend the quantity multiplier here. Okay, so what we need to do is to animate this value here. So therefore, to start with, what we'll do is set the initial value to, let's set that to 100. Okay, and then at frame 175, after the initial plume's finished, I'm going to turn on auto key and change this to, let's change it to this default in-out tangent for new keys, to this kind of fade in, fade out, or ramp in, ramp out curve type. Turn on auto key, and I'm going to set this value down to, let's set that down to about 75. Okay, you might need to do it twice. There we go. Then turn off auto key again, and I'm just going to choose out of the select by name this PF source 01 icon. So that's given us the two keyframes, one at frame 0, which is this value of 100 by default, and this one at frame 175, which is set to 75. Now what I want to do is I want to relocate this guy here all the way up to frame 160, otherwise by the time we start, the rate will be 75.52. So we want it at full throttle at this particular frame here, and then quickly tails off to the value of 75 here. So I can either drag and relocate that to frame 160. You notice at the bottom it's changing. There we go, come on, there we go. You notice it hasn't updated. It's actually a viewport update error, something that's constant in Max 2009 for relocating particle keys. Hopefully in 2010 they've changed it. Unfortunately I don't have 2010 running, so I can't confirm or deny that, unfortunately. But you'll notice that if I click off there and then undo to reselect the particle flow source engine, then you'll notice that the keyframe has been relocated and redrawn accordingly. Now we haven't obviously told the system where we're going to be positioning these particles, so therefore we need to tell it that they are going to be positioned where the icon is. So I'm just going to drag that and relocate that there, and just to make sure that the particles actually emit from the direct center of the engine, I'm going to change the location to pivot point, which is obviously the direct center of the icon, which is located here. So you see, there we go. So you can start seeing we've got a nicer tight array of particles here, which then fades off to this small amount over here. These particles are actually going to be spread out considerably more in a second, quite simply because we're going to be adding in some speed. Next thing we're going to do is let's add in the shape properties of these particles. Now, if you're running 3ds Max 2009 with the Creativity extension, or if you're running 3ds Max 2010, the next setup can be slightly different for you. However, I'm running a vanilla version of 3ds Max 2009, just quite simply because of cross compatibility, albeit you might notice a few small kind of different box 2 stuff in here. However, in box in box 1, or if you've got box 3ds Max particle flow tools box 1 running, or if you're running Max 2009 with the Creativity extension, or if you're running Max 2010, you will notice that the shape operator has actually been updated. So if I drop in a shape operator just onto the canvas here, just as an example, you'll notice that you'll have a ton more parameters in here. Now, this next step, if you're running these later versions or with the update, you have the ability to add in the sphere and also set the mapping coordinates in here. Now, by default, this does not have mapping coordinates assigned, so therefore any displacement that we add will not work correctly. So therefore, what we're going to have to do is cheat it a little bit with this vanilla version to add in the mapping separately by referencing scene geometry. Now, if you're running these later versions, what you can simply do is just change this shape type to sphere and the size to 25 as opposed to 12.5, which I'm going to do for the actual reference scene geometry. Reason being is because the size of the particle is derived from its diameter in particle view, and in the scene it's derived by its radius. So therefore the radius value is obviously going to be half the value of the diameter. So just to give you an example, what I'll quickly do is just on this other window here, if I just drop in a shape operator over here, I've just pulled that across. This is actually Max 2009 64-bit, which I've got the Creativity extension dropped on here. So you'll notice that shape, if I change that to sphere, it's 20-side sphere that we want to use. So the size in here, what we'd do is we'd set that to 25 and then turn on this generate mapping coordinates. Now, obviously we don't have that in this particular setup here, so like I say, we're going to have to fake it a little bit with the scene geometry. So to do that, it is simple. It's a simple case of just dropping in a geosphere primitive in here. So you know what, let's just do it in the top viewport for safety. There we go. Drop that in there. And then what I'm going to do is just set the radius to 12.5 as I mentioned before, and you'll more than likely need to drop this segment's value down to 1. By default it's going to be like that, which is going to be too much detail for us for this particular example. You'll get way too much geometry at render time, and the system will more than likely become a little bit on the unstable side. Basically the amount of material displacement is obviously derived from the source topology of the object, so therefore too many segments, you're going to have a lot more triangles at render time. So therefore I'm just going to drop that down. If you want to see more detail, then feel free to increase this as many times as you want until your system falls over. But for this particular example, we're just going to drop it down to 1 there. Okay, so back into particle view here. I'm just going to kill that, and I'm going to drop in a shape instance operator in there, and then add in this guy here. Okay, so the next thing I'm going to do is set the speed parameters. So by default we're using a long icon arrow, and the icons are pointing directly down, so that's in the correct direction. However, we need to increase the speed considerably, so therefore I'm going to set the speed value all the way up to 3000. We don't really need to set any variation in there. However, we'll set a little bit of divergence just to get a bit of a spread. We'll set that to value of 3. Okay, so if we view it in the camera viewport now and just quickly scrub through, we'll start seeing these guys. There's our ticks here. There we go. Being flung down. There we go. Okay, cool. Like I said, you'll notice some gaps between the particles. If you want to increase the amount of particles, feel free, but obviously it's going to increase the amount of geometry rendered out at render time. So just be aware of this. Okay. Okay, so the next thing I want to do is I want to hide this geosphere that we've just created, because we don't want to see it at render time. So I'm just going to hide that. And the next thing we'll do is set up the rotation. So we want the particles to be orientated differently as soon as they're born. So I'm going to add in a rotation operator there. Just relocate that guy, and random 3D is perfectly fine. We also want them to start spinning, so I'm going to drop in a spin operator in there as well, and we'll dial this spin rate down a touch as well, quite simply because we don't want to spin too fast. We want to spin a little bit with a little bit of grace to them, just to kind of give that turbulent plume effect. So we'll set the value of 100 in there, and a variation of 25. Next thing, we want to get all of these particles within here out of this event and start piping them into a common set of events which all of these guys are going to feed into. Okay, so let's add that in here by sending out those chaps there. So now it's just a case of instancing all these events across and wiring them up. So let's just quickly do that. Instance that, this, and this, and then wire them up accordingly. Now unfortunately what you'll get at render time at the present stage is a lot of repetition between these particles. You'll notice they're actually moving around exactly the same. So what we need to do is make some operators within these events unique in the way that we need to set these new kind of seed values in here, and so on and so on. So therefore, unfortunately, it's the case of going through every single one of these, making each one unique, and then clicking on the seed value. So I'm going to pause the video tutorial right now as I'm recording it and set all these values, because it's a little bit of a tedious process. And now they're all unique, as if by magic. So therefore, you'll notice that all these spin ones are different. Okay, rotation ones are different, etc., etc., and speed ones, and so on. So what we get now is a lot more breakup in the particle motion, and obviously the rotation and spin as well. Okay, next we're going to sort out a little bit of additional particle manipulation, i.e. what we're going to do is to help the deflectors, which we've obviously set up earlier on, do their job a little bit more efficiently, we're going to set up a speed by surface operator, which is going to help guide the particles away from this geometry here, and also the deflector that we've got down here, the kind of pyramid or triangle shaped geometry down at the bottom to direct the particles. So to do that, I'm going to drop in a new speed by surface operator here, which creates a new event, and then I'm going to rename this event as spawn and hold. Spawn and hold. There we go. And then wire the output of all of these guys into here. Okay, just going to maximise that so we can see what we're doing. And just to tidy things up, I'm just going to bring some of these around. Always a little bit of a pain when you've got crossing wires. Difficult to grab them. There we go. Okay. Okay, so now we just need to set some of the parameters within here. So therefore, what I'm going to do is change it to set speed continuously, so it's constantly affecting the particles as they get close to it, and then drop the speed down a little bit, down to about 150. Now, the surface geometry, we actually just want to add in the launch pad and the box direction objects. So therefore, I'm just going to come off out of here, switch to perspective mode, and then pick this guy and then this guy here as well. Okay. What I then need to do is we'll keep the direction as surface normals. However, we don't want the system to have an unlimited range. We only want to affect the particles when they get pretty close to it. So therefore, what I want to do is turn off this unlimited range. I'm going to take this range value down to 0 to start with, so there's the maximum influence of this speed is when they are right next to the geometry, but have a little bit of exaggerated fall off. So set it to 50. There we go. Now we don't want the acceleration limit to be too high. We just want the effect to be quite subtle. So we don't want any kind of bouncing or changing of sharp changes of direction. We want it to just be pushed gently away from the object. So therefore we can set the acceleration limit all the way down to 5. Now the next thing we want to do is to create some internal turbulence within the system. So we're going to use some additional particle spawning just to create some additional copies of the particles that are already present within the scene to affect the position and motion and direction of the main plume set. So we get a little bit of kind of displacement and a little bit of chunks of particles being flung out a little bit more, that kind of thing, just to create the size of the plume and create some internal turbulence. Now we could use wind space warps and that, but we get a nicer kind of effect with this because it's not so uniform. Okay, so to do that, I'm going to add in a spawn test. Now what I should do really is make sure that we're actually okay, because we are beneath the birth start value of 160. So what I think we need to do is make sure that you're all the way down at frame 0 before you start adding in some spawn tests. So otherwise you might get particles which spawn particles and so on and so on and so on, and your system might become a little bit on the unstable side. So at this particular stage, what I'm going to do, I think I'll actually just save that. I'm just going to call that sat5 finish, so you've got this to work with at the end of the day. Okay, so in this spawn test, what we're going to do is set the spawnable percentage all the way down to 20. So we only want a fraction of the particles to be sent out into this other event over here. And then what we'll do is we'll set the divergence. Actually, I think we'll leave that as is. I think we'll leave the divergence as it currently stands. Okay, so that's that one set up. So next thing we'll do is we'll start just controlling the motion of the particles a little bit. So at the moment there's a little bit of vigor to them. They're going pretty quick. You'll notice that there's starting to slow down a little bit because obviously we've got a bit of spawning going on in there as well. However, obviously these guys are going to be piped out shortly. So what I want to do is, as these particles are being channeled down here, when we start adding in some deflection in a second, they're still going to be travelling at their full velocity until the infinity. So therefore what we need to do is to get them to slow down and plume outwards. So to do that, in the top viewport I'm going to add in a let's add in a drag space warp in there. Okay, and then what we need to do is make sure that the time off is extended past the end of this length of the sequence. At the moment it's set to 0 and 100, so I want to set. I'm just going to whack that up to 1000. Depending on what version of Max you're using, you might notice that this x-axis is set to 5 and the y is set to 0 and the z is set to 0. However, we need these to be all exactly the same. I mean, in this particular version they are all set to 5, thankfully, so we don't need to make any changes in values there. But if you're running a version of Max which they are not all set to 5, then obviously make the change accordingly. Okay, so with that set up, what we then need to do is to set the introduce this to the system. So I'm going to add a force operator in here, and then choose the drag in there. So I'm just going to pull that across so you can see both. And then we don't need the full influence value here, so I'm going to drop that down to a value of about 600. Okay, so now if I go to the front viewport and scrub through, again we've got no displacement going on, no channeling going in here at the moment. So what we'll have, see these guys, these are actually the spawns. We should start seeing, if I wait for this to update, there we go, we've got, here's the drag that's kicking in. Alright, so these guys, when they're being channeled through here, they're going to be kept quite tight within the boundary of the geometry. So all these chaps here will actually be contained more within the actual main plume shape, as opposed to being scattered this wide. Okay, right, so let's go back into particle view and we'll add in the operator that we're going to use to drive the material. So we're actually going to use a material dynamic operator in here, quite simply because the material is going to change. It's going to change color and opacity, etc. over time. So it needs to procedurally amend. If we use the material static, it will just simply sample the color and the texture, etc. at the beginning of the scene. However, this one actually changes over time. Actually uses a little bit more memory up and changes the colors of the particles over time, over the particle's lifespan. So we don't need to worry about this at the particular time. We'll set this up in the material editor shortly and then drop it in a bit. Now, for the material dynamic to work correctly, what we need is a delete operator being added in here as well. that needs to be set to by particle age. Now the reason being is because for the particle age map that's going to drive the material's colors to work, the system needs to know exactly how long the particle is going to live for. So without a delete operator in there, the system simply doesn't know. So what we can then do now is, let's say that we actually want a relatively medium-sized lifespan to get the plume effect quite quickly, otherwise it's going to linger and linger and linger. So I mean, if you want to have a longer sequence and a larger plume, etc., then you can always amend these values afterwards. So but in this particular case, what I'm going to do is I'm going to set the lifespan to a value of 75 and a variation of 25. So we've got between about 50 frames and about 100 frames as well for the duration of the particle's lifespan. Now, for these spawn particles to get these out of the event, what we need to do is to make sure that the spawn particles and their parents do not directly interact immediately. So therefore, what I'm going to do is I'm going to add in a age test in here and set that just to a value of 1 with no variation, and set it to by event age. So the particles linger within this event, or the parent particles linger within this event for 1 frame, which gives enough time for these spawn particles to move out of the way, in essence. Okay. However, during this 1 frame duration, we want to make sure that the particles that are within this event still do not pass through any deflection. Do not pass through any geometry, so don't get any leakage going on. So therefore, what I want to do is I want to add in a collision test, this guy here, and then add in all of these 3 deflectors. Now you'll notice that we've got another one in here, this deflector 01. Now that's actually just set for the ground plane within the scene, this guy here. So that makes sure we don't get any particles going through the base of the scene. Okay, so what we should have now, if I'm just going to quickly just turn off this spawn just for interaction. I'm just going to go to perspective viewport, just pull that back. If I just scrub through, we'll see these guys update and plume outwards. A little bit of update lag. There we go. So this is what we're getting. Okay, so we've got the deflection off this geometry down here, which is set with the U deflector, and through this channel of this geometry down here. So we've got this nice kind of plume that's starting to come out. Okay, so what I want to do now is let's set up the parameters for the particles which have been spawned off here, for the turbulence ones, for these particles which are going to drive the turbulence within this event, well, the next event that we're going to drop in afterwards. Okay, so what I want to have is the same kind of parameters as we've got in here. However, obviously we don't need to have these particles renderable, so therefore we just need to have some of the motion properties. So therefore I'm just going to grab the force, delete, and the collisions. I'm going to copy those guys, and I'm going to instance them across to the canvas to create a new event. I'm going to rename this guy, let's call it turbulence. Turbulence. There we go, can spell. And wire the input of this event to the output of this spawn. So there we go. Okay, I'm just going to change the colour of this ticks to something that's a little bit different. There we go. Okay, so we can start seeing this in the viewport. So we'll just scrub through here. start seeing these blue particles coming through here as well. There we go. So these guys are going to be our particles which are going to affect the turbulence of these yellow ones down here. Okay. Now, because we don't want to have these guys linger for too long, we can actually just amend this delete operator, make it unique. I'm just going to take that back down here actually, make this unique, and then just going to kill the variation and just set the lifespan to 25 frames. So we just want to have them just to affect the plume initially as they're billowing out. Now we don't want to have them linger, there's no point, otherwise it's just going to be constantly affecting. We just want this initial burst just to send them out the way to create this bulbous effect here. So we only need them for about the length of about a frame or something like that. Okay, so next thing we want to do is we want to start creating the main motion of the particles. I'm just going to pull this across here like that and bring this across here as well. These are going to be fed out from this age test. However, again, same deal as before, we want to have some of the same parameters within this spawn hold. Spawn and hold event. So therefore, what I want to do, I'm just going to copy this speed by surface and just instance it to the canvas to create a new event. And let's label that first. Let's rename that as main plume motion. There we go. And wiring the input of this new event to the output of the collision and age tests. So that needs to go into there, and that needs to go into there. So now the age is passed, and then they get fed into this guy, or they hit the deflector and get fed into this. So therefore, it prevents any kind of particle leaking going through. Now, the next thing I want to do is just at this particular stage, because we've got all the events established now, what I want to do is I want to set up making sure that these systems don't cast or receive any shadows, just to keep render times down a little bit. So I'm just going to select all of these guys here. Okay, right click, go to properties. I notice that these are actually grayed out. It's quite simply because some areas within the system, actually it's these root events by default, have had receive and cast shadows turned off. Now we just want to turn those guys both off, and then we can just click on OK, and that's going to apply it to every single one. Now when you create a new event, it has the default parameters established, which is having cast shadows and receive shadows turned on. So therefore, if I add another event in here, this will actually go grayed out like we saw earlier on. Okay, now this particular event here, we actually don't want it to be renderable. We're just using it to affect the motion of the particle. So therefore, we can just right click on this guy, go to properties, and just simply turn off renderable in there. Okay, now to actually get these guys to affect this, these guys down here, what we want to do is to add in a keeper part operator in there. So first thing we want to do is we can add it into this turbulence, and then we can add it into this main plume motion afterwards. So we just want to get the particles to avoid each other in here, and have them the guys in here avoid these guys. So we can do that with one simple operator. So let's just drop in a keeper part, which is all the way up here. I'm just going to stick that all the way up to the top, because as it's event driven, we want the drag to be affected after the keeper part. Alright, so first thing we want to do is start setting some of these parameters in here. So therefore, the force and acceleration limit I think we'll leave as is. However, the range values we want to change slightly. So we'll set the core radius, we'll set that to 15, just increase it slightly, and the fall off zone will set that to 30, so it's just slightly bigger than the particles themselves, which will just simply create a slight displacement as they are passing through the main particle cloud, which is obviously going to be this guy down here. However, we actually want to set the scope to selected events, and we want to say it's the turbulence event down here. Now, the reason we're actually setting it and not using current event is quite simply because we're going to copy this guy here and then instance it across to that. Now, if we had it to current event, then this would affect just the guy in there, and it wouldn't be affected by these guys in here. Alright, however, we want to create a little bit of additional motion in here as well, just to, I mean, this is more kind of exaggerated to get them to fling out accordingly. However, we wanted a nice kind of graceful displacement in there as well, so I think we'll add in an additional keeper part in there as well. So let's just get these named up. Let's just rename these guys. So let's call that KA turbulence, and then we'll name this one as well. I forgot to do that to start with. O2. And this guy, I want to rename that as KA for keeper parts. Let's call that keeper parts spread. Alright. Slightly different properties in this particular one than this guy here. We don't want too much of an acceleration limit in there. I want to drop this down slightly, so I'm going to drop that down to about 500, and we're actually going to affect the core radius. We set that to 15 as before. However, this fall off zone, we're going to crank it right up to about a value of 1000, so we get a nice large wide spread being affected. Alright, this is basically going to kind of cause the particles to gradually spread outwards as they're being displaced by the faster moving ones. Okay, so the next thing I want to do is to have the same kind of properties within here, in this particular event here. So what I want to do is grab the force operator here, the material dynamic, here we go, let's grab these guys, and the delete and the collision, just to prevent any particle leaking going through within this event as well. Copy those guys, and I'm going to instance them across. So we should have exactly the same order here because I've selected them in order. So force, material dynamic, delete, and collision. Make sure you've got the same order here, and that the collision as is at the bottom, quite simply because it's the last thing that needs to be done to make sure that there's no leaking going through. Okay, so that will therefore give us this result here. If I just pull this up here, and there's a bit of a lag going on. The reason there's a lag going on here, now if you're using a vanilla version of 3ds Max 2009, the reason it's lagging slightly is quite simply because it's having to reference the instance geometry within the scene, i.e. the shape operator. If you're using Max 2009 and you're using the amended creativity extension version of the shape operator, or if you're using Max 2010, you'll more than likely notice that update speeds are considerably quicker because it hasn't got to reference scene geometry. Okay, so what I'm going to do, I'm just going to play through this slightly so you can start seeing this occur now. Okay, so we get this wider plume now that's been caused by this displacement, and these guys are pushing these particles out of the way as well. Okay, now bear in mind that this isn't exactly what you're going to get at render time. You will get a slightly different displacement, a slightly different collation. This is quite simply because the integration step is a higher value than what it is at render time, so you will get a slightly different distribution. Okay, so that is just about the system pretty much set up now. So we've got our distribution going on through our individual systems. We've got some turbulence being driven by this guy here, which is spawned off from this spawn and hold event, and these guys over here, which are going to be our main kind of renderable particles. Alright, so they'll fed out of the icon, rotation and size and speed parameters set in here, which are unique for each engine, fed into the main system, which are avoided by the deflection and also the speed by surface. Turbulence particles spawned off, motion parameters and material parameters set up, and also lifespan, and then they are fed into another event where you have the same properties in here, but they stay until they die. Okay, so the last thing to do in here really is to set up the material parameters that's going to be assigned to this particular particle system. Now, it's quite a straightforward procedure. However, I'll go through each one in turn. The reason being is because there are going to be some shaders in here that you more than likely haven't seen before or haven't touched on, or there's going to be some figure values in here that you're not going to be overly familiar with. Okay, so just by opening up the material editor, we're initially introduced to some of the materials that are actually being introduced to this scene by default, which is going to be this gradient ramp, which is applied to the sky, which is in the environment slot here, and a few materials which are assigned to the ground, the launch pad, and so on and so on and so on. All the other materials, like for example for the rocket, are already in here, and all the maps are already provided, etc. So they're just not present within the material editor at the particular time. However, you can obviously sample them and grab them accordingly. So that's the Saturn V main. They're actually being viewed as black here. Now that's actually quite important, quite simply because it's not a material error by any shape or form. It's simply a case of the material we're actually using here is an architectural design material which is only compatible with Mental Ray. It's not compatible with Scanline, which is what we are using to view the material editor, again quite simply because of update speeds. Alright, so I'm just going to kill that guy and then come back across here. Okay, so for the Plume material, what we're going to do is use a Mental Ray material, quite simply because if we don't need it, we can actually turn off any shading parameters or any surface parameters. So we actually only want to create a kind of pseudo volumetric effect. Now the reason I'm saying pseudo is because there's no actual ray marched volumes or anything like that that's actually being created here. It's all a shader effect. So therefore bear that in mind, i.e. if you decide to travel inside it, you might see some kind of intersecting geometry, intersecting lines, that kind of thing. So to create the Mental Ray material, just click on this material map browser, and we'll just choose this guy over here. Just going to pull that out of the way, and let's label this guy. Let's call that Plume, and I think just to get the material established, I think we'll just instance that across to the material dynamic operator there. Alright, okay, so now we can just go through. It's all assigned to the system now, so we can just go through and start creating our Plume material. Alright, so the first thing I want to do is to add what's called a transmat shader to the surface. It basically says that there's nothing going on within this surface. There's no information. It's just pass through information. Now, if we are just using a sorry about the updates, it just seems to be jumping around a little bit. If we are just using, say for example, we're going to be using a particular volume shader, so therefore if we just simply added that into the volume slot here, which is basically this guy, it would render out. However, to actually control opacity, we're actually going to be using a Luma shader, which is this mist one. Now again, it's basically a a material based effect. It's not actually a volume effect. This is a volume effect. The particle volume is a volume effect. However, it's going to be shaded with this mist, which is a material based kind of effect, kind of a fake, if you will. Now the issue is that particle volume doesn't need anything going in the surface for it to pass through. It's perfectly happy as it is. However, mist does. Now the problem is that particle volume doesn't have any kind of transparency or opacity values within it. It has something called extinction, which I'll cover in a bit. But in essence, it's simply a case of it determines how thin the fog is, or how thin the particular matter is. We actually need to control kind of the opacity of the fog. So there is no value in here. There is no property in this to be able to do that. However, there is in this. So therefore, for this to work, we need to add in the pass-through shader, which is this transmat physics shader here. So just drop that in there. I'm just going to label that. Let's call that null, because there's, well, nothing going on really. Okay, so just to show you exactly what we've got so far, I'll just bring up this tree here so we can start building that up, and I'll just show you the material edit, so the particle flow as well, so you can see we've got a plume there, that's gone into here, and then this has gone into this plume mental ray material there. Alright, so I'm going to leave this up at the present time. However, there are going to be some cases where I'm actually going to hide it. The reason being is because that if we start, or when we start messing around with gradient ramp maps, which are going to be used to derive colours and opacities and exclusions, etc., there is a little bit of an error with updates within this material map navigator, so therefore I'm going to close that at a certain point. So I'm just going to show you exactly what's going on in here so you can start seeing the structure being built up. Alright, so just to hide that, and I'm going to pull this up here so we can see exactly where we are and not get lost. Alright, so the next thing I want to do is I want to create the displacement for the material. So to do that, I'm going to add in this, let's add in the 3D displacement shader to the displacement slot in here, and I'm going to label that well, something completely obvious, which is going to be plume displacement. Okay, now what I'm going to do is I'm going to turn off this object independent checkbox here. What that allows you to do with it with it turned off, it allows you to scale the displacement based on the size of the object. Okay, so by turning it off, this displacement length value becomes obsolete. So therefore, the only value that we need to worry about is what's going to go on in here and what's going to go on in here. We don't need to worry about direction, strength, or the map. We just need to actually get the thing to displace outwards. So the extrusion strength I'm actually going to drop down to about 0.75 because we don't need it as strong as its default value, and to blend between no displacement, which we want immediately as soon as the particle is born, because obviously we don't want this massive plume sticking out at the base of our rocket. We want it to gradually grow over time. We're going to blend a procedural map, or a cellular map, which creates a nice kind of cloudy effect, with, well, black or nothing. So therefore that's going to be mixed by using a gradient ramp, which is going to be controlled via the particle age. So to do that, we need to add in a mix map into this displacement shader, 3D displacement map we've just set up, and let's rename this mix map. Let's call it Plume Displacement Mix. Okay, let's pull that across here so we can start seeing things build up. Okay, so the next thing I want to do is I want to set up the cellular map. So within this white slot, so we want to mix this, what's going to go on in here, with the black, which is going to be controlled by a map that we're going to drop in here in a second. However, let's just drop in the cellular map in here. I'm just going to pull that down so we've got a bit more real estate in here, and let's call that Plume internal shape. Just going to drive the displacement and also the shape of the plumes and also the opacity. Okay, so because we don't want the geometry to kind of float over the object, what we want to do is set the source coordinates to explicit map channel, which is going to lock onto the mapping channels of the particles themselves, or the reference geometry in this particular case. Okay, so however, what I want to do is I want to have some additional kind of animation that's going on within the material. So we want to get this kind of displacement effect, which is bobbling around and kind of moving and contorting as it's animated, not just kind of rotating and moving. We want it to kind of basically phase. However, cellular map doesn't have a phase value. However, we can kind of fake it again simply by animating the W offset value here. Now, the problem here is that if I suddenly scrub all the way to foam 500, we're going to get a severe lag because of the particle system. So at this particular stage, what I'm going to do is I'm going to go back into my particle view and turn off every single one of these guys here, so that what I can then do is navigate all the way to frame 500, change this keyframe type here, this curve type here, to linear, turn on auto key, and I'm going to set this W value to a value of 2. Alright, now you can't see anything within here quite simply because this is showing the end result. So if I just turn that off and scrub through, you should see some slight color change. There we go. Alright, now obviously this is also what we're going to kind of get at render time on our particles. The map's too big, so therefore we need to obviously amend it. Now I'm turning auto key off because I obviously don't want to animate the size of the cellular chips or cellular characteristics. So therefore what I want to do is just change this change the size value down to about 0.5. I want to increase the spread, so we're not going to get as many of these black areas. There's going to be none of these kind of like harsh dark areas here. It's actually going to be more of a grad, so therefore pull that across there. And to get some additional detail in, I'm going to turn on fractal and then increase the amount of iterations to about a value of 5. Okay, with this cellular map set up, what we can now do is go through and set up the gradient ramp, which is going to drive the displacement. Now again, what I've done is I've turned off, I'm going to get rid of this guy. I'm just going to show you this as it currently stands now. I would advise you to hide this guy as well if you've got it up already, quite simply because if you start pushing flags around within the gradient, this thing will more than likely go into a loop, and this here will start flickering away and flashing, and it'll all get very horrible and painful and hair pulling, etc. So I'd say also at this stage, save the scene. Okay, so I'm going to close that guy and then add in a gradient ramp map into this slot here. Gradient ramp, there we go. Okay, again this thing seems to be jumping around all over the place. Quite simply because I've got my screen size set so low. Label this. Let's call that Plume displacement control. So Plume displacement control. And then what I'm going to do is, before I start setting all this stuff up in here, I'm going to set this to mapped and then drop in a particle age map into this source map slot here. Alright, funnily enough, I'm going to call that particle age, and let's just go back up to our gradient ramp. Now what's going to happen now is that the particle age map, which is being driven by the delete operator within the system, because obviously it tells the particles exactly how, or tells the particle age map exactly how old the particle is in turn going to drive the color distribution from this gradient. Now you might think, well, why don't I just use this? Now you could, you know, there's no question about it. You could just simply just use this particle age map as opposed to using this gradient ramp. However, within the gradient ramp, you have a lot more control. So you can add more flags in, you can add more color keys, etc., etc. You can push things around a lot more easier than just using the standard 3 swatch and 3 value setup that you have within the particle age. I mean, there's another thing. What you could do is obviously enable the color map and start pushing it around in here. I've got a redraw issue here for some unknown reason. Let's just go back to there. It's not drawing it for some bizarre reason. There we go. You can start pushing things around using this, etc., etc. However, I'd say the best thing really is just dropping this particle age in there and then just push it around within this gradient ramp. You get a lot more control and a lot more kind of versatility within the color distribution. Okay, so what I want to do is ensure that we have no displacement within our particles all the way down here, and then we've got kind of full displacement over here. Now we want the particles to displace relatively quickly, so what I can do is just grab this guy here and let's relocate that guy to around about position 18. So we have a nice steep attack in displacement, if you will, from none all the way up to, well, some. But I think we'll actually increase that amount even further. Let's set that to 200. So we get quite a large displacement going quite early on. Now, unfortunately, you don't see this within the viewport, even if we show in the particles as geometry, and you won't really see it in here either. The only time you'll actually see it at render time. So these are values which I've actually derived through developing the tutorial. So you will hopefully be able to see exactly this when it comes to render time. One other thing to note, if you're using Max Design, chances are you've got this real world scale value turned on. There's a possibility you will get some different results at render time. Same deal in the cellular map, you might get some different results as well. So just be aware of this. If you've got this turned on by default with any of the gradient ramp maps, later on in this scene, make sure you just turn this real world scale checkbox, just turn it off. Okay, so that's our displacement set up now. So what we can now do is start setting up the volume properties, or the volume shaders within here. Okay, so because we actually want to have the mist shader controlling the parti-volume shader, we need to obviously have the mist shader within the system first. So let's just drop that guy in here, and let's label it, well, it's driving the opacity, so let's call that Plume opacity. Alright. Now there's not really much that we need to do within here by default, just simply adding in a few extra shaders. However, there's a nice little checkbox here which is Effect Alpha. It's off by default. However, if you actually want to composite this effect in at render time, what you can simply do is just check this guy in, make this entire lot shadow map material, so you only get the plume rendered. You only get the plume renderable, so therefore you can comp it into your shot and then push it around in the comp as you see fit. Without this guy turned on, you won't get anything. You'll get the rendered effect, but you won't get the alpha channel. So if you actually want to have the alpha channel, turn it on. I'd suggest turning it on and leaving it on by default. Okay. Next thing we want to do is to drop in an output map into this transparency slot. Now the reason we're doing that is to invert whatever's going on in here. Now we're going to be using the cellular map to drive the transparency. However, bear in mind that's exactly what it is. It's transparency. It's not opacity like any other kind of material that we have, like for example in standard materials, etc. It's not opacity, it's transparency, i.e. the whiter and lighter the map, the more transparent, as opposed to the more white the map is for the opacity. And if it's dropped into an opacity slot, the more opaque it will be, which is obviously the other side of the coin. So therefore what we need to do is invert what we've got in here. Okay, so at this stage let's just label it. So let's just call it Plume Transparency Invert. Okay, make sure this output rollout's expanded, and then just click on invert. So therefore your white, which obviously there's nothing in there, it's white by default, goes to black. And what we then need to do is to create a little bit of transparency at the edges of the particles, just kind of like creating a bit of a fall off. So therefore let's drop in a fall off map within here, and then let's call that Plume Edge Fall Off. Okay, so that we have more density at the front than at the side, obviously we need to flip the colours. So therefore, don't forget we are actually going to be inverting this. Alright, so from this point onwards, let's just treat it as if it was opacity we were dealing with, as opposed to transparency. So it's an easier way of thinking about it, so we don't get confused. Okay, so still believing we're dealing with a opacity slot, for example, we need to then drop in the relevant information, the relevant shapes and the relevant texture that we need within this particular section within here. However, same deal as before, we need to get the cellular map to fade out over time. So to do that, we can simply just drop in a mix map in there like we did previously, and let's label it, let's call it Plume, well, Plume Fade Out. That's exactly what it's going to be doing. Alright, next thing we want to do is, again, same as before, we want to deal with the cellular map in here, but we actually want to add a little bit more contrast to it and a little bit more kind of shape. So therefore what we can do is just drop in a output map within this color 2 slot, and let's call that Plume Clamp, because it's going to be clamping off or manipulating the cellular map that's going to be dropped in here. Alright, so I think what we'll do is we'll drop that in there first. So let's go to Material Editor and let's just instance this cellular map across. Alright, and then we can simply go and enable the color map in here. We've got a bit of a redraw issue going on. There we go. You might not have these issues, but unfortunately, because I'm viewing this on a separate monitor and with a reduced screen size, it's causing some update issues. Okay, so the next thing we want to do is we want to design the map so that we've got a little bit more of kind of a bulbous top here. So we've got more bright areas. We're in essence kind of amending the gamma of the map slightly. Okay, maybe just pull that across a touch. Right, there we go. Okay, so the next thing is we need to control exactly how this output is going to be mixed through with this black. So again, same kind of deal as before. What we need to do is use a gradient ramp map and control it via particle age. That's just simply a case of just dropping in a new gradient ramp as before into here, and let's label that Plume fade out control. Okay, so there is going to be a little bit of an issue with what we need to do with the source map, but I'll cover that in a second. However, what I'm going to do is just amend the gradient flags here. Now, we're actually going to be using the invert within the source map, the gradient within the particle age map. We're going to need to flip the colour, so therefore black's going to be white and white's going to be black, so therefore we need to flip the gradient here. So therefore, as opposed to having black to white, we're going to have white to black. It's obviously the end of the scale. So I'll explain the reason why in a minute. However, just let's get these set up. So therefore I need to relocate this guy to, let's pull you up to position 70, and I'm going to set this to let's see, 225. Alright, so therefore what we're going to have is it starting from this side going that way as opposed to starting from that side going this way, quite simply because we're going to have to amend this source map in here. So I'll switch that across to mapped and then drop in a particle age in there, and let's call that particle age inverted. To invert it, I'm going to swap those colours. Now, the reason I'm having to do this is quite simply because there is a little bit of a bug within gradient ramp. There is quite often an occasion where this colour here and this colour here will kind of bleed through. Now, when I was developing the tutorial, because we're actually going to be using this tree structure that's driving the transparency within the density of the mist shader, because of this kind of bleed, there is a little bit of an overlap which causes a few problems, especially when you've got geometry to geometry or particle geometry to geometry interaction. Like, for example, if a particle is kind of half on, half off this area around here, it will be the particle will be shaded correctly. However, the overlap won't be. It will be very, very bright and very, very intense. Through developing the tutorial, there was an issue with regards to if I simply inverted the map, there was an issue. If I simply took the original particle age and dropped it within a output map and then inverted it, there was a problem. Even swapping the other sides of the gradient, there was a problem. So this was like a bug fix solution, unfortunately. So it's basically because of the gradient and also the density misrepresenting it and misreporting it back through to the shader, and therefore giving an artifact at render time. However, this fixes it. It's a strange way of fixing it, but it does actually fix it. So for future reference, just be aware. I mean, Gradient Ramp has these kind of problems. It has these kind of problems, not necessarily only to do with being driven by particle age or being driven by maps, gradient types. It also has a very similar problem when dealing with lighting, for example. You will more than likely see a bleed at, if you set it to lighting, you will see a bleed at the highlight end and also at the shadow end. You might get a very fine line from the other side of the gradient at the shading end, and also or a pinpoint mark within the gradient at the lit end that's derived from the shadow end. There's a little bit of a bleed going from one side of the gradient to the next. So that's pretty much the problem it's caused, that's needing this particular solution. Alright, so anyway, back to the tutorial. Now that's our transparency pretty much set up, so we can go through and just step backwards and so on. Got the invert in there. Now what we need to do now is again set up the density. Now the density is this guy down here. Now density is driven the same kind of way that opacity is driven, i.e. the lighter the map, the more dense the end result will be. So therefore we don't need to worry about this value here, and so we don't need to worry about this value over here. However, what we need to do is we don't need to have the inverse in here. So therefore what we can do is we can just copy this, go up to our density slot here. We need to drop in an output map just to exaggerate the intensity of the map. So we need to drop that guy in. Let's label this Plume density intensify, because that's exactly what it's going to do. And I'm going to set the output amount to, let's crank that all the way up to a value of 20. It's going to be very, very intense now. And then let's simply just instance the Plume edge fall off map to the map slot of this output map. So therefore this will take the non-inverted existing map tree that we already have set up within transparency, and that also therefore drives the density accordingly. Alright, so that's that already set up. So that's our mist setup now. So therefore what we can do now is just go through and set up the volumetric effect, which is going to be dropped within this solid color slot here. Now the problem is that if I click on this slot here, we need to find the parti-volume shader. Now as you can see, we can't see it. It won't let us choose one. So what we need to do, again, it's a little bit of an error in the system, quite simply because this it's thinking that it's not allowing you to use this particular type of shader within this other shader. It's thinking that they're not compatible. Well, in fact they actually are. So just to get it in, what we simply need to do is go to a new slot, and we can just pull up this parti-volume, this guy here, parti-volume physics. Okay, I'm going to label this at this particular time as Plume volume, and I'm simply going to copy this guy and then instance it across. Now if you try dragging and dropping it, it won't work. Okay, it will not work if you drag and drop. It has to be copied and then instanced across. Okay, it will not work any other way. Okay, so within this Plume volume parti-volume physics shader, what we need to do now is set some additional parameters in here. Now at first glance it might look a little bit confusing. What the hell are all these small kind of numerical values, and it all looks a bit scary. It's not. Mode we're not actually really going to be concentrating on. Mode simply just has got a two state value, 0 and 1. 0 is the one we're actually going to be using, which is obviously its default. 1 simply allows you to set height and distances. So for example, if you turn it on 1, what you can ensure is that the effect is only beneath a certain value, over a certain height within the scene. Scatter color is something we're going to be using to set the color of the effect, like for example the fire colors and the smoke color and so on. Extinction is a value which gives us the ability to have more dense or more fine particular matter. Now this is actually again going to be all driven by maps. So normally our values vary between, well, the current default value which is in there, which is 0.001, which is going to be very, 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 if you have a light in there, it's going to be very, very bright, but quite simply because it's not going to be very dense. The more dense you actually want the material, the higher the extinction value is going to be, which is the reason why earlier when I was saying that we don't actually have any kind of transparency control within this. We only have the extinction value. The problem is with the extinction value is that the lower we actually have it, the lower we actually have the extinction value, the lighter the shader will get. It will get very, very, very bright, and then all of a sudden just pop off when the value reaches 0. So what we're going to have is this all driven by map. So we're going to have a gradient ramp drop within there, which is going to drive the color, then go almost to black. So we've got a very kind of dark material. So at the end result, you might think that the actual smoke plume is going to be a little bit too dark. So you can always raise the color of the gradient ramp flags just to get a little bit more luminance in there. However, be very, very careful and do it very, very subtly. Do several test renders just to make sure you got the color right. However, quite simply because as the extinction is being animated again via particle age and via gradient ramp, there is a high possibility that you'll get some very, very bright areas within the actual smoke plume. So just bear that in mind when you're actually designing it. Okay, so the next parameters are to deal with R, G1 and G2. Now R basically blends the two G values together. Now ranging from a value of 0 to 1, you can basically mix between the two parameters. G's basically magnitude controls the width of light. Well, it's something akin to like a fall off on a spotlight cone, for example. So for example, 0 is more diffuse and 1 is more like a kind of pinpoint sharp spotlight. So the other thing to need to consider is the actual positive or negative value. Like for example, a negative value between -1 and 0 controls the backscattering of the shader, and the positive G value controls, say for example, between 0 and 1 controls forward scattering. So a careful blend between the two, and obviously intensity and therefore weighting will obviously give a nice decent result. Like for example, in this particular one, we're dealing with Rayleigh scattering, so we're dealing with, like for example, of 0.5 in this particular example for the value of R. So that gives an equal blend between G1 and G2. The value that's derived for G1 is a minus 0.46, and then G2 is 0.46. So we have a negative value for G1 and a positive value for G2. Non-uniform, we can add some value to, just to kind of break up the effect so it doesn't look as doesn't look as uniform, to be perfectly honest. However, we've got a lot of kind of density control and a lot of opacity control that's already been set up within the system anyway, so therefore we don't really need to worry about this particular point in time. Now you can feel free to add this in at a later date, play around with it by all means. However, bear in mind that it will affect render times and might also make the effect or the end result look slightly patchy. You will more than likely need to tweak the step sizes. Now that's something that we're actually going to do next. Now again, referring back to Afterburn, if you've again used it, you will be familiar with step lengths and step sizes and so on. Now the way to look on this is that the smaller the step size, the more accurate and the more smooth and effective the end result will be. However, this has obviously an adverse effect on render time. So because we're going to have a fair amount of motion blur thrown into this scene, we don't really need to worry too much around about step lengths. If you decide to change this after the tutorial's finished, what you can therefore do is drop these down to get an improved quality of render. However, bear in mind that this will result in the scene being more accurate, and therefore you will more than likely get different results to what you've originally got, what we've originally got at the end of this tutorial even. So therefore what you'll more than likely need to do is to change the intensity and change the brightness or change the extinction values just to kind of build that intensity back up. We're actually using kind of a bit of a blend between extinction values and step lengths to actually gain the intensity on this particular tutorial. So if you do decide to make the scene more accurate, or even decide to increase it if you're having some issues with the render times, you might need to tweak the extinction values or the brightness of the scatter color within the gradient ramp. This is quite a simple procedure of actually just amending the RGB or output level values. Okay, so in this particular example, what we're going to do is set the minimum step length to a value of 5. Actually set it quite high, considering that the particles are going to be the particles are relatively they're going to be relatively large after the displacement. However, bear in mind that the current sizes are only around about a value of about 25 if we're using the creativity extension, or they're only a value of 12.5. So we do have quite a small amount of step size to start with anyway. Okay, having the default value of 0.1 is a little bit too extreme, to be perfectly honest. So having this, increasing this minimum step length to a value of 5 is going to be totally sufficient for our needs for this particular example. However, we're going to increase the maximum step length to 50. So we've got a variation between 5 and 50, depending on whether or not the system needs to refine down that much or not. Okay, so that's pretty much the majority of our plume volume setup. However, what we need to do next is to make sure that we're only using specific lights within this particular shader. Now, the reason behind that is because these particular lights have no shadows applied. When you actually have a shadow casting light applied to this, you won't get any kind of feathering through the effect. Well, not as much as you'd hope anyway. There is normally a bit of a linear fall off, and you'll quite possibly get a end result where the effect looks kind of black at the end of the day. It looks like it's totally saturated black within there, and it's lost all color and lost all illumination. So therefore, we've got an additional set of lights for the sunlight. We've also got an additional set of lights for the rocket plume. So we have two sets of lights for the plume, one which is illuminating the rocket itself and also its surroundings, and another one which is just simply illuminating the plume on its own. Okay, so to do that, what we'll do is we'll just add in the relevant lights that we need. So therefore we need the direct plume and all these omni plume ones. Okay, so any additional lighting within the scene, like for example the I'll just pull this up, the director one, which is our main sunlight, which is a shadow casting light, and also where are we? Here we go. These free spots, which are also shadow casting as well, will not affect the intensity of the plume. So therefore, when a shadow is cast across them, it won't have any effect. So the next thing we're going to do is set up the scatter color, which is going to be the color of our smoke plume. So what we'll do is drop in a gradient ramp map in there, and then let's label that plume color. Okay, same deal as before, we're going to use a particle age map to drive the color distribution, so therefore we need to change this gradient type through to mapped. And to drive it, we can just use the particle age map that we used beforehand, so we're not going to have any errors with this particular one. So we can just go to material editor and let's choose the particle age one there. So instance that across. Okay, then we'll just chip back up to the gradient ramp map. Alright, the next thing is just going to be a case of just adding in a ton of flags to this gradient design here, and these are ones I've actually derived from developing the tutorial. So we're going to have like a light color set up to about here, which is then going to go to black. So this is like when the particles are born, this is when they're going to die, so we need the bright areas around here, and then it goes to smoke. Alright, so the first thing I want to do is I'm going to bin this flag at position 50, and then set the one at position 0 to, again, these are values which I've already kind of derived. So these are going to be RGB 240, 200, 170. So we've got kind of like almost like a flesh colour, like a pink colour even, but this is going to be very, very intense, so it's going to be very, very bright. So we're going to get this kind of nice kind of pink / orange / yellow fall off color, which is going to mix through nicely with the light color as well. Okay, so the next one I want to drop in is at position 2. Let's just drop that in there. That one's going to be RGB 240, 165 and 78 for the blue, so we've got a bit of an orange in there as well. Next one I'm going to drop in is around about position 12. Alright, and this one's going to be 168, 90, 52, so we're getting slightly darker now. Next one is around about position 22, so we're falling off quite steeply through to a darker colour now, which is going to be 76, 50, 38, 38, there we go. And then finally going all the way to 33, we're getting pretty dark now, and that's going to be 12, 11, 11, so it's just slightly, very slight red hue to it. And then finally the one at position 100, I'm going to set that all the way down to black. Alright, okay, so just look at our tree now and how intense it's actually getting now. So we're actually here within the plume color. Alright, so that's our setup for our plume color already set up. So the next thing we need to do is set up the extinction. So the extinction itself, again, same kind of deal as before. So we want to add in a gradient ramp. Let's drop in a new one. Here we go. This one we want to label it as we'll label it as plume intensity. That's pretty much what it is at the end of the day. Same kind of deal as before. What we want to do is use this kind of grayscale grad. So anything that's kind of black, as I mentioned earlier on, is going to have a low extinction value, and anything that's white is going to have a high extinction value. So if we say that's 0 and that's 1, so we want values between, so 1 is going to be quite dense and 0 is going to be totally transparent. However, as soon as you get to a value of 0.001, like for example here, what we're going to have is a very, very bright color. So we want to make sure that this kind of fades off to around about this particular region here. That's when the smoke starts to kick in, or just before the smoke starts to kick in. So we've got this bright area. In essence, the shade is saying that it's going to be very, very faint. It's going to be not much particular matter. We're actually using the opposite at the end of the day. In realistic terms, what we'd have is we'd have like a quite a dense area here and a light area here, a faint area here, quite simply because obviously you don't need the smoke to fade out. However, bear in mind that we're driving the entire opacity of this thing by the mist shader, which is further up the stack. So therefore this we're just using, we're kind of faking it, kind of massaging it just to kind of drive, well, just to drive intensity, not to drive opacity. Alright, so we need this thing to fade out quite quickly to around about here, and then have a higher extinction value around about this region here, so we don't get these really, really bright smoke colours. We want the brightness to be confined around here. Alright, so what we need to do is what we can simply do is just relocate this flag at position 50 to about position 30, right about here, and then let's set the colour to around about 230. Let's increase that. Alright, so it's not gone totally to white, but we've got a little bit of extinction within there, but not a great deal. Alright, so next thing I want to do is same deal as before, drop the gradient type as to mapped, and then instance across the particle age across there as well. Alright, so that's pretty much our shader set up. Now the last thing we want to do before we actually start rendering the thing is to set up the motion blur. Now the motion blur is actually going to be derived from the motion of the particles, obviously, and the camera motion. However, there are two main initial types of motion blur which is applicable within mental ray. One is the standard motion blur, which is based on samples. However, there's another type which uses the fast rasterizer. Now, the problem is that this can take quite a while to render out. They both can actually take quite a while to render out. One gives a cleaner result, which is obviously the standard motion blur, which is a standard sample rate motion blur, which is default within mental ray. The fast rasterizer, it bakes it in on the fly as each bucket is being rendered out. However, again, it can take a little while to do it. A nice, easy, quick way of doing it is by using a method that's akin to the image motion blur method within the standard scanline renderer, and to do that we simply just need to add in the relevant output shader. So we can just click on this guy here, make sure we're on new, and then choose the HDR image motion blur shader there. Now obviously you can't see any parameters within this particular shader here, so to actually access this we can just drag and drop that into the material editor, and then we have access to the full gamut of shader parameters. Now we can actually leave the shutter duration to 0.5, which it gives like a motion blur for half a frame. So basically saying that it gives like a kind of filmic response at the end of the day. Now what we can do to actually get the particles just to blend together a little bit nicer, it's kind of fake and it's kind of like detracting from reality a little bit, but we can just boost that up to about a value of 1. If you actually want to increase the amount of particles within the scene to kind of close the steps and so on and so on and so on, what you can do is leave the shutter duration at a more realistic 0.5 duration. However, this value of 1 will kind of smear things together a lot nicer, and you won't get so many kind of hard edges or linear steps and what have you. Okay, so that's pretty much the end of the setup. So let's just go through. I'm just actually going to go and re-enable the particle systems, and then switch to the camera viewport, and I'm going to set an output path which is just rendering from frame 160 to 500. So I just want to look at the actual plume itself before we sign off. So I'm just going to render out a few frames now. Pause the sequence first, render out a few frames, and then we'll rejoin it afterwards. Okay, so here we have the actual scene rendering out. It's not doing too badly. Render time is roughly around about 17 seconds a frame at the present time. This will increase possibly up to about a region or about 2 minutes a frame when the plume gets a lot more dense. You'll notice some kind of interspaced particles around about this particular region here. Like I say, but they all kind of get blended together at the when the motion blur is applied. Now you may notice a error on rendering when you actually come to render this thing. This is actually normal. The scanline option within the renderer tab, which is over here, if I just pull this down, this guy is actually enabled, so therefore the HDR image motion blur won't motion blur the background without that guy turned off. So if you feel like you actually want to do that, then you can always turn off the scanline option so you get the background rendered out. Now the background isn't really visible in this particular shot at the present time. It's currently out of frame. It only kind of nudges in right at the end, but however, if you want to actually turn that, you want to make sure that the motion blur is actually applied to the background, then feel free to turn off scanline, or as what I've done, just turn off the errors so you don't actually see them. You may notice a little bit of grain in the rendering. I mean, at the moment we're actually using quite a low samples per pixel. We're actually using the default values of quarter and a maximum of 4 for the minimum maximum, and box filtering for the sampling. these aren't exactly, you know, production quality rendered settings at all. I mean, obviously you need to increase the amount of samples per pixel and change the filtering type as well. Something like Mitchell, for example, is normally relatively decent. So I can actually pull on that at all. I don't think I can. No. Okay, so the other thing what I would suggest is, if you want to boost the quality of the render, is also tweak this edge length down here. You might want to drop that down to, for example, drop it down to a minimum of 2 pixels for the edge length, which will give you a more kind of defined pattern in here, especially if you're dealing with production quality render, that kind of thing. Worst case scenario, what you might want to do is tweak this maximum subdivision value, increase it maybe up to 64 or something like that, which will give you again a more refined result. However, the actual Plume's not looking too bad at the moment. You notice this light area here. That is one kind of thing to look out for, especially when you're dealing with the exclusion. By this particular point in time, the color is actually starting to change from the orange through to black. Now, the black isn't actually true black. It's not, you know, RGB 000. It's, you know, slightly higher than that. So therefore, the exclusion is, in essence, kind of multiplying it. So you are getting this kind of light area coupled with the intensity of the light, which actually has an attenuation on it. So the further away the light is, the less intense the effect gets at the end of the day. But we do get these kind of nice little bursts travelling through because of the random variation of particle age. So we get these kind of nice bursts travelling through in the actual in the end sequence. So if I just cancel that at this particular stage, because that seems to be working okay, just going to save this out so you've got a copy. So what I'm going to do is I'm just going to pull up the RAM player and show you one that I produced earlier on. Okay, so this is the final sequence. We've got a 500 frame sequence, playing it out at 24 frames a second at the moment, which actually no, we're actually dealing with 25, so let's pull that to 25. Yeah, so we just play through the sequence. So we've got a nice kind of handheld motion coming around. We've got these arms coming back, the arms coming back here, plumes billowing out. You'll notice seeing these little kind of bits leaking through in its variation. It's not looking too bad. Obviously, this could obviously be a lot better around here. This is a tutorial. The thing to remember here is this is a tutorial. This is not a production quality render. You wouldn't see this kind of effect in a feature, especially not these kind of jagged areas around here. But this is not looking too bad around here. This needs to be kind of confined a little bit more. You might notice a little bit of leaking through in the engine geometry with the particles and what have you. That can be attributed to two things. Number one is obviously the size of the particles, and also the other thing is the amount of motion blur that's been applied. It might be leaking through or over the top of the actual geometry itself. So just be careful with that. Apart from that, it's not looking too bad. We've got some nice kind of rolls going on here. That specific billowing that's going on around there, looking not too bad. This is looking a bit kind of fighty around here, quite simply because of the amount of different random rotations that are going on. It might be worthwhile for you to change it slightly in future. If you just want to switch back to particle view, if you want to, say for example, amend this spin rotation, this spin value, change the spin axis, for example, change it to speed space follow, that kind of thing. Maybe have some kind of relax within this main plume motion, so when the particles slow down, the amount of spin changes and it reduces, so that it doesn't kind of fight and try and change direction or try and change angle, which would give kind of like a bit of a flicker, kind of a stuttering motion. So make sure that it kind of slows down and stops and doesn't kind of start moving around erratically. Apart from that, it's not looking too bad. So hope you've enjoyed the tutorial. Hope it's not been too painful for you, and see you in the next one. Cheers.